So in the previous video we learned how to insert an element at the end of a linked list. In this video we are going to learn how to insert an element in between a linked list. And insertion and between can only happen when there is a linked list that is already predefined. So suppose that we already have a predefined linked list and this is the code for it. We have taken insertion at end code here, and we are going to define another function in this class for insertion and between. So I'm going to define that class here, that function here, sorry. So insertion between self, this is going to be our function name. For better understanding, let's take a visual representation of a linked list that is already predefined. So 3, which is connected to 4, and this is connected to 5. Now for insertion and between, we are going to ask the user to print the position in which we want to insert our node. So enter position. We will take a POS variable and take the input for it. And then we are going to ask for the element that the user wants to insert. So I'm taking item variable here and taking its input. For insertion and between case, we need two pointers which are going to be pointing at the head. So I have taken two pointers here, PTR and previous, which are pointing at the beginning of the linked list. So our start pointer is here, which is always fixed. We will take our PTR pointer this and our previous pointer this. Now we need to place both our pointers to their appropriate position to insert that node. And this here is our logic to place the pointers at their position. We will go through it step by step to understand the procedure that is happening here. Before that, let's make a node for the element that we want to input. So our node is created here. Suppose that we want this P node to be inserted at the beginning of this linked list. So our input for our position is going to be 0, and let's take our item here to be as 2, and the pointers are going to be allocated at the beginning and the loop is going to run. So as you can see here, it says that position greater than 0. So our position is 0 here right now, and 0 greater than 0 is false, so the loop will not run and it will move to this part here. Then our node is going to be created, and here we are going to write the logic for insertion at beginning. Since our pointers have not moved, we are going to write if ptr equal to self dot start. That means that when the ptr has not moved and it is at the starting point itself, then p dot next equals to self dot start, and self dot start equals to p. So it here says that the address of the node that we have created just now is going to be pointing at self dot start, which is here. So our new node was 2, wait, Yeah, so our no node was 2 and it is connecting to this node here, as it says that the p dot next equal to self dot start, and self dot start was pointing here, so the address of this node is going to be pointing at this node. And here it says that the self dot start pointer is going to be pointing at p now. And why is that? Because since our node has been inserted at beginning, so we need to place our head pointer at the beginning of the linked list. So instead of pointing here, it is going to be pointing at the first node here. So our start pointer is going to be pointing here. Now suppose we want to insert a node at the end of this linked list. So we are going to take position as 4 here, and the element we are going to take it as 7. So I have taken the element 7 here, which is going to be inserted at the end. And now the pointers ptr and previous are again going to be pointing at self.head. The self.head was here, so both the pointers are again going to be pointing at this position here. So my ptr pointer is here and previous pointer is also here. Now in our while loop here it says that position greater than 0. Our position is 4 here, so 4 greater than 0 is true, and previous equal to ptr, that is the value of ptr is going to be assigned to the previous pointer. In this case it's going to be the same. So and here ptr is equal to ptr dot next. So our ptr pointer is going to be pointing at this node here, as in the address part the address of this node is present. So ptr is equal to ptr dot next is that ptr is going to be now pointing here, and position we have decremented it by 1. So our ptr pointer is now pointing here. I have changed the color for the ptr pointer for convenience. Our pos variable has become 3. Now the loop is going to run again as 3 is greater than 0. The previous pointer is going to become equal to ptr. So our previous pointer was here. It is now going to be pointing at this node here, as it has become equal to it. And the ptr pointer is going to jump to our next node. Our ptr pointer is this one and previous pointer is this one. And POS is again going to be decremented. Now it is going to become 2. 2 is greater than 0. Previous pointer is again going to be equal to this one here. So and PTR pointer is going to jump to this node. The pointers are placed now, and our POS is again going to decrement. It is going to become 1 and 1 is greater than 0. Our previous pointer is again going to be equal to our PTR pointer, that is it is going to point at this node here, and our PTR pointer is going to point at the address part of this node. So the address part of this node is none here right now, as it is not connected yet. So our PTR pointer is equal to none right now, and our previous pointer is pointing at this node here. So our previous pointer is here now pointing at this node, and our PTR pointer pointing at its address part of the node. Now our POS pointer is going to decrement again. It is going to become 0 and the loop is going to break. Our node for that item is going to be created, and since PTR is not pointing at self.start, it is pointing at none, we are going to create another condition for that. So and if as our PTR pointer is none here, so PTR equals to none, then the previous dot next equal to p, that is our new node 7 here. So this line of code here is saying that a previous dot next, so our previous pointer was pointing at this node, and previous dot next, that is the address part of this node, is going to contain address of p node, which is 7. So a connection between these two nodes is going to be created. So this was the case for beginning and end. Now it's time to insert at between. So let's suppose that we want to insert our element 6 here at between 5 and 7. We have taken position here 4 again, and the element is 6 here, and PTR and previous pointer are again going to be pointing at this node. The same process is going to be repeated here, except that PTR pointer is now going to be pointing at this node here, since it was connected with this node. So PTR pointer is pointing here. Now let's write the code for between. So else, since the beginning and the end condition have been completed here, it is time for the only condition left is between. So else or previous dot next is going to be pointing at a new node here. So the previous pointer the previous pointer is here, and it's saying that the address part of this node is now going to be connected to this node. So if the address part is now connecting to this node, so the connection between these two nodes have been deleted and connection between these two nodes is made. Let's delete the connection between these two nodes and make the new connection here. Now to connect this node with this node, we are going to write that p dot next equal to ptr, as the address part of this node is going to be pointing at this node. Since our ptr was pointing here, this makes sense here that p dot next equal to ptr. The address part is now going to be pointing at this node. So let's make the connection between these two. So with this, our linked list is created. Now let's create an object of our linked list class p equals to ls, and we are going to first create a predefined linked list here. So I'm calling the function insertion and here. Then let's run. Enter number of elements. So we are going to take 3 elements first here. The first element is going to be 3, then 4 and 5. Now we are going to call our function insertion and between here. So p dot insertion between, and let's also traverse the linked list to check. Then call the function again and run, enter position. So let's take the first element here. So 0 position, element 2. The linked list is created as 2 3 4 5. So this part of the linked list is created now. Now let's take the 7 part here, which is at insertion end. So let's call the linked list again, enter position as 4, enter element 7. As you can see that the node 7 is inserted at the end here. So 2 3 4 5 7 here, this one here. Now let's insert at between. So position here is again 4, element number is 6, and as you can see that our linked list here is displaying 2 3 4 5 6 7, which is here 2 3 4 5 6 7. So, and with this our insertion at between code is complete. In the next video we are going to learn how to delete element from a linked list. So till then, stay tuned.